In this lecture, I want to talk about linear models. So we're going to just talk about equations of lines and graphs of lines and how they're related. We will use a lot, especially with tangent lines in calculus. So understanding how to work with lines, especially slope and point slope form, will be very important in calculus. So the unique feature, kind of the defining property of a line, is that its rate of change. What do I mean by the rate of change? I mean, so if I can just draw on a triangle here, I mean the change in y over the change in x. This little triangle, also known as a delta, kind of represents change. So we're looking at the change in y, the amount that so if we go from, let's say this point right here, and let's call that x1, and the y value that's associated with it, we can call it y1, and then I have another point up here on the line, right? So I could call this x2, and this would be y2, right? So this point right here, it's hard to fit it in there, but it's x1, y1. Those are the coordinates of it. And then this point up here is x2, y2. So what I mean by rate of change is how does y change with respect to x? So every time I go over by a certain amount in x, how much does y increase by? Or if this were decreasing, a negative slope, every time I go over by a certain amount of x, how much does y decrease by? And it's constant anywhere. So another way to think of it is I could draw like a smaller triangle between 2 points here and here, and my change in y over my change in x would be equivalent to what it would be here. I could make a huge triangle and look at the change in y over the change in x. It's constant. Everywhere along this line, the change in y with respect to x is constant. That is the defining property of a linear function. So if we want to find this rate of change, like I said, we want to find the change in y over the change in x. Now, how would I do this? Well, you see here, this is my delta y. It's how much y has increased by. So one way to, y, not x. This is my delta y. So the way to find that change is to subtract y1 from y2. All right, so that gives me my change in y. And then to find my change in x, this distance here, I could subtract x1 from x2. So I would end up with this. And in terms of the graph of a line, we would call this m, or we denote it as m, but we actually call it slope. It's the slope of the line. So let me give you a specific example, because I know we have a lot of letters and notation going on here. Let's take a look at a specific example let's just find the equation of a line that goes through the points 2, 3, and 4, 7. So we would say that 2, 3 is like right here, and 4, 7. So this would be the point 2, 3. Up here we have the point 4, 7. And we want to find, this is just kind of a rough sketch, but something like this. All right, here's the line. First, we want to find the slope of that line. In other words, how does y change with respect to x? I think you probably already know, but it only takes 2 points to define the line. Once I have those 2 points, there's a unique line that goes through them. So I'm not finding the equation of a line that goes through these 2 points. I'm finding the equation of the line. There's only one. All right. So again, if we look at kind of think of this as a little triangle here. What's the change in y? Well, y goes from 3 to 7. So I can subtract 3 from 7. And the change in x, well, this over here is 4, and that's 2. So I get 4 over 2, which is 2. So that's my slope of this line. Notice, though, it doesn't matter if I subtract these points. So what I did is I took 7, subtracted 3 for the y, and 4 and subtracted 2. But I could have just as well done it the other way. If I take 3 and subtract 7, and take 2 and subtract 4, then I end up with negative 4 over negative 2, which is still 2. All right? Notice the important thing here, this point 4, 7, or here, that they stay together. I don't want to get these mixed up, right? This has to be the same point. This is the x value, this is the y value. Then over here, this is the other one, 2, 3, or 2, 3. As long as we keep those, you know, we can switch them this way, but we don't want to get our x and our y's mixed up, right? So in other words, we wouldn't want to do 7 minus 3 over 2 minus 4, because 2, 7 is not one of our points, and neither is 4, 3. This would be getting them mixed up. We don't want to do that. So that's the main thing you have to keep track of here. It doesn't matter which point you subtract from which, as long as you're consistent. Okay, then, you know, we have, this is, in order to get the equation of the line, we should notice that for any point on this line, so let's say here's a point down here, x, y, that the slope between 2, 3 and xy, this slope right here, should still be 2, right? So in other words, y minus 3, all right, because that's the change in y. We're going from 3 here down to whatever this y value is, over x minus 2. So again, we have 2, well, this x value minus 2 gives me this distance right here, and the y minus 3 gives me this distance. We know that because the slope is constant, that's going to be 2, right? We found it up here. So y minus 3 over x minus 2. I could have just as well have said y minus 7 over x minus 4, but that's going to equal 2. Now if I just multiply both sides by x minus 2, so that those cancel, I get y minus 3 equal to 2 times x minus 2, and that is my point slope form or equation of a line. All right. So here is the y value. We can call it maybe y1. Here is my slope. Here is my x value. All right. So in general, I guess I'll have a little bit of space up here. In general, the general point slope form is y minus y1 equals m times x minus x1, where this x1, y1 is a specific point on the line, like 2, 3, or 4, 7. The x and the y just stay x and y, and then, of course, that's the slope of our line. Okay, so that is point slope form. Some other things about slope that you should already have learned at some point, but just by way of review, if the slope is positive, then our line, as x increases, y increases, right? So as you go from left to right, it goes up. If our slope is negative, then it goes the other way, right? So as x increases, y goes down. As we move from left to right, it goes down. We could have that m equals 0. That would give us a horizontal line, right? So we would just have something like this. You know, so for example, that could be the equation y equals 2, right? So there is no x because the coefficient of x, if we come back to this, if m is 0, then we would just end up with y minus y1 equals 0. We could add y1 to both sides and just end up with an equation like this. And then finally, we could have m is undefined. All right, and this happens when we have a vertical line. So maybe something like this. And let's talk about why m is undefined on a vertical line. So this could be, for example, maybe this is the line x equals 3. That means all along the line x equals 3, y varies. So for example, this could be the point 3, and the y value could be 4, and then like down here, maybe we're at 3, negative 3. So for the slope formula, we have that m is the change in y, or 4 minus negative 3, gives us the change in y, over the change in x, which is 3 minus 3. So basically there is no change in x, right? This would give me 7 over 0, but dividing by 0 is undefined. So this is why the slope of any vertical line is undefined. Okay, now just to make the connection from the point slope form, notice before we ended up with the equation y minus 3 equals 2 times x minus 2, and we could distribute that and get 2x minus 4, right? So now we have y minus 3 equals 2x minus 4. Add 3 to both sides, and I end up with y equals 2x minus 1. Now, I will begin by saying that this point-slope form is going to be more useful to us in calculus than this form, which you may be more familiar with. Many students are. This is called the slope-intercept form, because we can read off the slope and the y-intercept. That is the y-intercept. Going back to the lecture on intercepts, how do we know that's the y-intercept? Well, the y-intercept occurs when x equals 0. So if I put in 0 for x, guess what I get? Negative 1. All right, so that is always going to be the case here. This whole term will disappear when we put in 0 for x. So that number right there will always be the y-intercept. So although you may be more familiar with the y-intercept form, and it's probably more useful in terms of graphing, right? Like if I wanted to graph that same line, I know that it would go to the point negative 1. My slope is 2, so I go up 2 and over 1. So I have a point here. Here's my y-intercept, and, well, missed, but you get the idea. Right? It's supposed to go to that point. There's the graph. So it's very easy to graph from the slope-intercept form, but very often in calculus, we are going to have a point and we're going to have the slope. And so this will be the easiest one, at least to start with. If you need to graph it, you might want to rearrange it like we did here to graph it using the slope-intercept form. Finally, there is what we call standard form. So let me use a different color. Kind of start something a little bit new here. So standard form of a line is ax plus by plus c equals 0. For example, we might have 5x plus 2y plus 10 equals 0. Now, one advantage of having, again, real quick, how would I know that this is a line? Well, nothing is squared, right? I just have an x term, with a coefficient, a y term with a coefficient, and a constant. I have the same thing here. It's just it's rearranged so that we've solved for y. And I have a similar thing here, except, I've got y minus 3. But any of these three are equivalent. We can just rearrange them. What this form is particularly useful for is finding the intercepts. So if I wanted to find, for example, the x-intercept, then let y equals 0. All right? So if I put y equals 0, then this term here becomes 0, and I'm just left with 5x plus 10 equals 0, or 5x equals negative 10, x equals negative 2. All right, so negative 2, 0 is my x-intercept. And then, likewise, to find the y-intercept, let x equal 0. So if I let x equal 0, I'm just left with 2y plus 10 equals 0, again, because that just goes to 0. Then I get 2y equals negative 10, so y equals negative 5. So again, putting in 0 for x gives me negative 5 for y. And then, this is pretty simple to graph then, right? I've got 2 points. I've got the point negative 2, 0, right here. That's my x-intercept. My y-intercept is at 0, negative 5. So 1, 2, 3, 4, 5. So I would end up with this being my line. All right. Now, of course, I could rearrange this and get it into slope-intercept form as well and graph it that way. But this is a useful form just for finding the intercepts and graphing it using the intercepts. Okay, then the last thing I want to talk about with lines is parallel and perpendicular lines. How do we find two lines, or how do we find a line that's parallel to another line or perpendicular to another line? So suppose we have two lines, y equals m1 x plus b1. That's just for our first line. It has a particular slope and a particular y-intercept. And then y equals m2 x plus b2. This is my second line. These subscripts just denote that these aren't necessarily the same m and the same b. Okay, so two lines are parallel if m1 equals m2, all right, and they are perpendicular if m1 equals -1 over m2. All right, so first we take the reciprocal and we take the negative. Another way to check what's equivalent, if I were to multiply both sides by m2, we would get the product of the two slopes would be -1. All right, this is a little bit more useful. If I know one slope, I can find the other one by taking the reciprocal and making it negative. But if I'm given two slopes, I can test it just by multiplying them to see if they're -1. So let's just do a quick example here. Let's suppose I have, I want to know the equation of a line. So the equation of a line through the point 3, 5, first, that's parallel to y equals 2x plus 1, and then secondly, that's perpendicular to the line y equals 2x plus 1. So our solution here. So for A, we know that the slope must be 2, right? Because if to be parallel, they have to have the same slope. So I know my slope is 2. I know I go through the point 3, 5. So y minus 5 equals 2 times x minus 3. This is my point slope form, right? I know my slope. I have a point. I could rearrange that if I really wanted to, but I don't. All right, and then the second, now if m equals 2 in this equation, then the negative reciprocal, my new slope, will be -1/2. And I still know that I go through the point 3, 5, so this is going to be y minus 5 equals -1/2 x minus 3. So that would be the relationship between parallel and perpendicular lines can be explained by the relationships between the slopes. This is an example of how I could find the equation of a line that's parallel or perpendicular to another line. All right, so that does it for the linear models. Very important that you know how to work with these, and this should cover, at least review the topics that you'll need for calculus.